Good morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering in MLR Institute of Technology, Hyderabad. Today I am going to tell you about guidelines for installation from a subject called Industrial Electrical System. In this lecture, I am going to tell about few guidelines for installation, the load calculations and the sizing of the wire. How to decide the size of the wire based on the current flowing through the particular wire. What are the general rules and guidelines for installation? These are some of the rules and guidelines. Like, first one is protection. Install a 2-pole linked main switch and a fuse unit near the point of entry of the supply cables. That is near the entry point. You can see here, near the entry point, we need to connect a 2-pole linked main switch and a fuse. A protective device should be connected near the main entry for all the supply cables for protection purpose. Second one is conductors. Use conductors that are long enough. We should use the conductors which are long enough to safely carry the load current. Means the conductor length should be more to safely carry the current, as well as during the maintenance also it helps if the length of the wire or the length of the conductor is more. The third point is safety. Ensure all the conductors are safe. That is, the insulation is done properly without any cracks or without any breaks. We should ensure whether the conductors are in good position or not with proper insulation. Next point is sub-circuits. Connect each sub-circuit to a distribution fuse box. Sub-circuit should be there, and we should connect each sub-circuit with a separate fuse for it, and that should be placed in a distribution fuse box. Like, you can take an example of a particular distribution box. This distribution box is being divided into different sections like this. It is being divided into different sections like this, and each section will be having different fuses or different MCBs. You can say this one as one sub-circuit, this one as the second sub-circuit, this one as third sub-circuit, fourth sub-circuit. So, different sub-circuits will be having different fuses, and all these sub-circuits are being placed in a single distribution box. Fuse board. Next one is fuses. Protect each line. It protects each line or phase or positive. Each line which is phase or positive with a fuse. For each line, a fuse should be connected that will have the appropriate rating. That means, to this particular line, based on the load which is connected to this particular line, based on the load maximum capacity, based on that, a fuse should be connected. So, the fuse always depends upon the load which is being connected to the line. Next one is isolation. Provide a separate means of isolation for each circuit or equipment. We should provide a isolation for each circuit and equipment. So these are the some general guidelines before installation. In a brief, I can say, like the first one is protection, second one is conductors length should be more, and protection, a 2-pole main switch should be there. Third one is safety. We should ensure that all the conductors are in a safe condition with proper insulation or not. Next, sub-circuits. Each and every sub-circuit should have a separate fuse and it should be connected in a single distribution fuse box. Next one is fuses. Protect each line. Line you can call it as phase or positive. Should have appropriate rating based on load connected to it. Next one is isolation. Provide a separate means of isolation for each circuit. We should provide a separate means of isolation for each circuit and that should be connected to the distribution fuse box. So these are the guidelines. These are few more guidelines like earthing. In general, electrical installations are earthed for safety reasons and for protection purposes to limit the over voltages to provide a path for electrical discharge. And for legal requirements also. So earthing is mainly done for safety reasons, for protection purposes and to limit the over voltages and mainly for the providing a path for the electrical discharge. Next point is load points. If any light or fan subcircuit, the number of load points should not exceed 10. So a particular subcircuit can have a maximum quantity of 10 electrical elements to be connected to it. So maximum of 10 elements should be connected to a subcircuit, and this subcircuit, the fuses of this particular subcircuit, the MCBs of this particular subcircuits are being again connected to the distribution main box. Next one is power subcircuits. Should not exceed 3000 watts. The maximum limit or power of power subcircuit is 3000 watts and has a maximum of 2 power points. It should have a maximum of 2 power points with a maximum rating of 3000 watts. Next one is fuse rating. How can we decide the fuse rating? The fuse rating should be less than half of the lowest cable size capacity in any circuit and should not exceed 5 amperes in any subcircuit. The next point is the other general rules. The other general rules for residential electrical installations include like the ambient temperature, the material of construction where the cables are located, the type of installation and the influence of neighboring circuits, So these are the general rules we need to consider. The electrical installation guide is a technical guide that helps the electrical designers and contractors design electrical installations according to the standards. So before installation, we need to check this electrical installation guide, and based on the guidelines which are being provided in this particular electrical installation guide, based on the guidelines, we need to install the circuits, install the sub-circuits, based on the sub-circuits, we need to, based on the loads which are being connected to the sub-circuits, we need to decide the range or the rating of a particular MCBs, and all those MCBs should be placed in a distribution box. By taking a brief of this, maximum of 10 sub-circuits, maximum of 10 electrical equipments for each sub-circuit, and all are placed in a single distribution box which is being placed. Here you can see which is being placed at the point of entry, which is being placed at the point of entry. So these are some of the rules and guidelines for installation. Load calculation and sizing of a wire. How can we do the load calculations and how can we decide the size of a wire? Here are some of the steps for calculating the size of a wire based on the load. First one is identify the load. Determine the electrical load the cable will provide, such as lighting, motor or other equipment. We can take the lights, fans, motors, geysers. So we should first identify the different types of loads and their ratings. Calculate the voltage drop. The second point is to calculate the voltage drop. The voltage drop is the reduction in the voltage that occurs as the current flows through the cable. The voltage drop is the reduction of the voltage that occurs during the current flow through the cable. Factors such as the current, length and material of the cable. Factors like current, length and material of the cable affect the voltage drop. So, the voltage drop mainly depends upon the current and the length of the material and the material which we are using for the cable. The voltage drop of 3% or less. Voltage drop of 3% or less is generally acceptable. 3% or less is generally acceptable for low voltages. For low voltages, but for specific requirements may vary based on the application and regulations. Based on the application and regulations, the range may vary, but for the standard thing, 3% or less is generally accepted. The third point is determination of minimum cable size. Consider the minimum cable sizes based on the load. Based on the load. Continuous current carrying capacity should be there. The current carrying capacity should be there. That means the cable should carry the current continuously. Voltage drop should be decided. Short circuit temperature rise. The cable should be resistive to this short circuit temperature rises also. Next one is earth fault loop impedance. So, based on this, the cable size is decided. Here you can see generally the load is when the grid voltage is 220 volts, the empirical load per square wire is about a kilowatt, about a 1 kilowatt. Each square of copper wire can carry about 1 to 1.5 kilowatt. A copper wire can carry a power of 1 to 1.5 kilowatt, and the aluminium wire can carry about 0.6 to 1 kilowatt. So the copper wire can 1 to 1.5 can carry 1 to 1.5, and aluminium can carry 0.6 to 1 kilowatt. Therefore, it is sufficient to use only one square copper wire. It is sufficient to use one square copper wire for an electrical appliance with a power of 1 kilowatt. To carry 1 kilowatt, one square copper wire will be sufficient. Specific to the current, when the short distance power transmission, the general copper wire can carry about 3 to 5 amperes. 3 to 5 amperes. The copper wire can carry 3 to 5 amperes per square. 3 to 5 amperes per square. The heat dissipation condition is good to take 5 amperes per millimeter square. 5 amperes per millimeter square. And it is good to take 3 amperes per, it is not good to take 3 amperes per millimeter square. So based on the current carrying capability, the length as well as the diameter of the particular wire or you can say cable is being decided. The length as well as the diameter of the cable is being decided based on the current carrying capacity. If it is an aluminium wire, the wire diameter should be 1.5 to 2 times that of the copper wire. The diameter should be 1.5 to 2 times that of the copper wire. If the copper current is less than 28 amperes, it is 10 ampere per square millimeter. You can say 10 amperes per square millimeter square. If the copper current is greater than 120 amperes, if it is greater than 120 amperes, it is 5 amperes per millimeter square. It is 5 amperes per millimeter square. So, the next topics will be based on the main switchboards and amperage of a board, where the main switchboard is being placed and what are the different types of main switchboards and how to calculate the amperage of that particular board, like what are the sub factors that we should consider for calculating the amperage. All these things we will discuss in the next lecture. Thank you.